Welcome viewers, in this video we will see the solved problem based on the transformer test, OCSE test, so part 2. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we will go to the topic. First we will see the problem 1. Obtain the equivalent circuit of a 200 bar 400 voltage 50 Hz single phase transformer from the following test data. OC test, open circuit test, 200 voltage 0.7 ampere 70 watts on the LV side, low voltage side. Short circuit test, AC test, 15 voltage 10 ampere 85 watts on the high voltage side, HV side. So the data is available as OC test and AC test data are available. So then other data are V1 equal to 200 voltage, primary voltage. I0 is 0.7 ampere. First we will see the OC test, right? The voltage applied to the winding is 200 voltage because the OC test is performed on the low voltage side. And no load current is 0.7 ampere, no load power input to the transformer is 70 watts. So from that we can find the transformation ratio V2 by V1, 400 by 200 equal to 2. The transformation ratio is 2. First we are considering the OC test. So from the no load power W0 is V1 I0 into cos pi naught. From that we can find cos pi naught equal to W0 divided by V1 I0. By rearranging this equation we can find. The W0 is 70 watts and V1 is 200, I0 is 0.7. All these values are available, V1, I0, W0. So that is equal to 0.5. Cos pi naught equal to 0.5. If cos pi naught equal to 0.5 means pi naught equal to cos inverse 0.5, that is 60 degree. So the no load power factor is 0.5. The corresponding angle pi naught, the angle between no load current and voltage is 60 degree. Now we can calculate the magnetizing component and working component. The magnetizing component IW equal to I0 cos pi naught. So the I0 is 0.7, cos pi naught is 0.5. So that is equal to 0.35 ampere. So the IW is calculated. Then the magnetizing component I mu equal to I0 into sin pi naught, that is 0.7 into sin 60. The pi naught value is 60 degree. So by simplifying we got 0.606 ampere. So now we calculated IW value and I mu value, working component and magnetizing component. And other two parameters what we need is R0 and X0. During the load and no load condition we need 4 parameters. One is IW, I mu, R0 and X0. The current IW is flowing through the resistance. The current, magnetizing current is flowing through the inductance. So we need to find R0 and X0 value. R0 equal to V1 divided by IW, working component. Already we discussed that the iron loss happen in the resistive. The magnetizing current mean it is inductive. So 200 divided by 0.35 is 571.42 ohm. Similarly the reactance V1 is X0 is V1 by I mu. So that is equal to 200 divided by 0.606, it is 330 ohm. Now we calculated all 4 parameters IW, I mu, R0 and X0. So that we can draw the equivalent circuit for the open circuit test. Now we will go to the short circuit test, AC test. So the secondary short circuit voltage is given 15 voltage. The secondary current I1 equal to IS equal to 10 ampere. This is the short circuit current. When the short circuited, the current flowing. Then short circuit power equal to 85 watts. Now we will find the Z02. Z02 equal to VSC by ISC by referring the secondary circuit. So 15 by 10, these two values are available, VSC and ISC available. So it is 1.5 ohm. Then Z01 referring the primary side is Z02 divided by K square. So that is 1.5 divided by 2 square, it is 0.375. So we got the Z02, Z01 value. Then WSC equal to ISC into RS, R02. the power input, power during the short circuit, WSC equal to ISC square into R02. So that from that we can find the R02 value. R02 equal to WSC divided by ISC square, that is 85 divided by 10 square, that is 0.85 ohm. So these data are available. Now we calculated the R02 value and Z01 already calculated. Now refer the equivalent circuit. This is for the no load condition, that is a open circuit condition. This R0 and X0. This R0 and X0 we already calculated. Similarly, IW and I mu also we already calculated. Right? This R01 we need to calculate R01. We see later. This X01 also we need to calculate R01 and X01. This Z01 is available, R02 is available. From that we can calculate R01 and X01. Now we will see how to calculate R01 and X01. So this is the equivalent circuit. This refers the no load component. This refers the short circuit components. So R01 equal to R02 divided by K square. R02 already calculated 0.85 divided by 2 square, that is 0.2125. So the R01 is calculated. X01 equal to square root of Z01 minus R01 square. Z01 square minus R01 square. Z01 is calculated 0.375 minus R01 also we calculated 0.2125. So that is equal to 0.308 ohm. Right. So in the equivalent circuit, this R01 and Z01 also calculated. So by using this all the value, we can draw the equivalent circuit. Now we'll go to the second problem. A 2000 bar 200 voltage transformer has primary resistance and reactance of 2 ohm and 4 ohm respectively. The corresponding secondary values are 0.025 and 0.04 ohm respectively. Determine the equivalent resistance and reactance of primary refer to the secondary. Total resistance and reactance refer to the secondary. Equivalent resistance and reactance of secondary refer to primary. Total resistance and reactance refer to the primary. So we need to find the both referring primary as well as secondary values. So the data is given are, the V1 is given 2000 voltage, B2 is 200 voltage, primary voltage is 2000, secondary voltage is 200 voltage. Then R1 is given 2 ohm, primary side resistance, primary side reactance X1 is 4 ohm. Similarly, secondary side resistance 0.025 ohm, secondary side reactance 0.04 ohm. So we know that we can transfer all the data from primary to secondary as well as secondary to primary. For example, this R2 and X2 can be transferred to the primary side. Similarly, this primary data can be transferred to the secondary side, so that the calculation become easier. Right. So that is called a equivalent resistance. The separate video available, link is given in the description box. So accordingly, it is saying referring to primary, referring to secondary. So before going to that, we will find the transformation ratio V2 by V1. So 200 divided by 2000, it is 0.1, is the transformation ratio is 0.1. Now we'll go to the first one. The first one is the equivalent resistance and reactance refer to the primary winding, refer to the secondary, R1 dash and X1 dash. R1 is the resistance of the primary, R1 dash mean while it is transferred to the secondary side, refer to the secondary side. Similarly, X1 is the reactance of primary, X1 dash mean it is transferred to the secondary side. So that equivalent value is R1 dash equal to K square into R1. So while transferring to the secondary side, it will give the same effect. So that in order to make the same effect, it is multiplied by K square. Similarly, X1 square equal to K square into X1. So the K value already calculated, 0.1 square into R1. R1 value is given 2 ohm. That is equal to 0.02 ohm. Similarly, K square into X1. X1 value is 4. 0.04 ohm. So this R1 and X1 is nothing but the equivalent resistance and reactance of primary while transferring to the secondary side. R1 means primary value, R1 dash mean it is transferred to the secondary. While transferring, we are multiplying with the k square. Then we will go to the second division, R02 and X02. So, this is nothing but equivalent resistance and reactance referring to the secondary side. It means the primary resistors are transferred to the secondary side. Primary resistance and reactance is transferred to the secondary side. So, that R02 equal to R2 plus R1 dash. R2 is the resistance of secondary. R1 is the resistance of primary. R1 dash mean it is transferred to the secondary side. Right. So, by adding this we will get the total resistance referring to secondary side. Similarly, reactance also. Right. So, R2 value is 0.025 plus R1 dash, that is we calculated. R1 dash is 0.02, that is 0.045 ohm. Similarly, X02 equal to X2 plus X1 dash. So, X2 is already available, 0.04 plus X1 dash is we calculated, that also 0.04. So, that is 0.08 ohm. Right. So, these two are nothing but equivalent resistance of a transformer referring to the secondary side. R0 to X0 to means secondary side. Same thing will go for a primary side also. We will find R2 dash, that is the third question is equivalent resistance and reactance of secondary referred to the primary. So, this R2 is the resistance of secondary, while transferred to primary it become R2 dash. Similarly, X2 become X2 dash. How will you find R2 dash? Is R2 divided by k square. So, in the previous case it is multiplied by k square. So, while transferring from secondary to primary, normally it is divided by k square. So, 0.025 divided by 0.1 square, it is 2.5 ohm. Similarly, X2 dash equal to X2 divided by k square, 0.04 divided by 0.1 square, it is 4 ohm. Right. So, these two are the equivalent resistance and reactance of the secondary while transferring to the primary side. Now, we will find the fourth one, total and resistance and reactance referring to the primary. This one secondary, these two are secondary, total resistance referring to the secondary, this one referring the primary. Right. So, R01 equal to R1 plus R2 dash. R2 dash mean secondary resistance transferred to the primary. R1 is 2 ohm, R2 dash just now we calculated 2.5 ohm. So, it is 4.5 ohm. Similarly, X01 equal to X1 plus X2 dash. X1 is given 4 ohm, X2 dash we calculated that also 4 ohm. So, totally it is 8 ohm. So, this is the equivalent resistance and reactance of the primary referring the primary winding. So, in this we discuss about the SC test as well as the resistance and reactance transfer from primary to secondary as well as secondary to primary. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. Link is given in the description box. Thank you for listening.